In this video, we are going to look at examples of what constitutes a legitimate probability assignment. We'll also be calculating some simple probabilities using formulas for the probability of a single simple event, probabilities of events A or B, disjoint events, the complement rule, and our general multiplication rule. First, let's evaluate some probability assignments. If we look at part A, going across, we have 0.10, 0.55, 0.20, and 0.15. In order for a probability assignment to be legitimate, the sum of all probabilities within the sample space must sum to 1. Also, there can be no negative values. If we sum the values in part A, we see that we have a legitimate probability assignment, as the values sum to 1. For part B, we do not have a legitimate probability assignment. If we look at the values going across, 0.33, 0.33, 0.73, and negative 0.39, we see that we have a negative value. Since there can be no negative values in a probability distribution, this is not a legitimate probability assignment. Let's look at part C. Going across, the probability values are 0, 0, 1, and 0. This is a legitimate probability assignment. The values are between 0 and 1, and the sum of all probabilities within the sample space sum to 1. Finally, looking at part D, if we sum the values, 0.22, 0.33, and 0.44, the values do not sum to 1. Therefore, part D is not a legitimate probability assignment. Next, let's look at calculating some basic probabilities using the probability distribution to the right. The table represents the probability distribution for Scrabble tiles. The column to the far left indicates the letter. The middle column indicates the frequency. So, for example, for the letter A, there are 9 Scrabble tiles with the letter A. There are 4 Scrabble tiles that contain the letter L. The sum of all frequencies is 100. So we know that there are 100 Scrabble tiles in a bag. To the far right, we have the probability for each. So, for example, if you were to draw 1 Scrabble tile from a bag at random, the probability of getting the letter L, for example, would be 4 out of 100, or 4%. Determining that the probability that the letter we chose was an L was pretty straightforward. We know that it's 0.04, or 4%. We use the formula for the probability of a single simple event, which tells us that the count of all outcomes in L divided by the count of all possible outcomes will give us our probability. Now suppose we are asked, if you pick a tile at random from a bag of Scrabble tiles, what is the probability that the letter you choose is an R or an A? The probability of choosing an R or an A, if we pick a tile at random, these are disjoint events. In other words, we can pick an R or we can pick an A, but we can't pick a tile that's both R and A. Therefore, we'll use the formula for the probability of events A or B, which are disjoint events. The formula states, to find the probability of A or B, it's equal to the probability of A plus the probability of B. In our case, we're looking at the probability of choosing an R or an A. So I rewrote the formula. The probability of R or A is equal to the probability of R plus the probability of A. The probability of drawing an R is 0.06, and the probability of drawing an A is 0.09. If I take the sum of these two probabilities, I get 0.15, or 15%. Now suppose we're asked, if we pick a tile at random from a bag of Scrabble tiles, what is the probability that the letter we choose is not an E? In order to determine this probability, we need to use our complement rule. The complement rule helps us to determine the probability that an event does not occur. The formula states the probability of A is equal to 1 minus the probability of A complement. In our case, we're looking at the probability that the letter we choose is not an E. The probability of not E is equal to 1 minus the probability of E complement. We know that the probability of drawing an E is 0.12. So all I need to do is plug this value into my formula. 1 minus the probability of E our probability is 0.88, or 88%. In other words, the probability that we do not choose an E is the complement of choosing an E. Now suppose we are asked, if you pick a tile at random from a bag of Scrabble tiles, what is the probability that the letter you choose is an 8? Well, if we look at all of our choices, we can see that there is no 8. Scrabble tiles are letters, not numbers. Therefore, the probability of choosing an 8 is 0. Now let's look at some applications of the general multiplication rule. Suppose we pick 3 letters in a row. What is the probability that all 3 are E's? Because we're drawing the Scrabble tiles out of the bag and not replacing them as we go, we need to apply our general multiplication rule for AND events. The general multiplication rule for AND events states the probability of A and B is equal to the probability of A times the probability of B given A. This is the formula that we use when we're drawing items without replacement. We know that there are 100 Scrabble tiles in the bag and that 12 of those tiles are E. So the probability that all 3 are E will look like this. For our first draw, the probability is 12 in 100. For our second pick, because we have taken one tile away, there are 99 left. Because one of the tiles was an E, there are 11 E's left. Assuming that the third tile we draw is also an E, there are now 98 tiles left in the bag, and 10 of those are going to be an E. So, it's the probability of E and E and E, all in a row. We multiply these fractions together and take the decimal equivalent, which is 0.001. I can convert that to a percent by multiplying by 100 or moving 2 decimals to the right. So we'll say our probability is 0.001 or 0.1%. As you can see, it's extremely unlikely that you would draw 3 E's in a row from a bag of Scrabble tiles. Now suppose that if you pick 3 letters in a row, the third tile is the first one that's an A. What is the probability that our third tile would be the first one that is the letter A? To determine this, we're going to apply our conditional probability rule again. We know that the probability of getting an A is 9 out of 100. Therefore, there are 91 tiles that are not in A. So, using the general multiplication rule for AND events, we'll set up our formula as follows. The probability that the third tile is the first A is equal to the first tile not being an A, which is 91 out of 100. When we draw our second tile, there's only 99 tiles left in the bag. The second tile is not an A. We have 90 left that are not A's. Now the third tile is going to be an A. We know that there were 9 tiles that had the letter A on them. So 9 in our numerator divided by the number of tiles left in the bag, which is 98. Now we simply multiply across to take the product of these fractions and represent it as a decimal. When we do this, our decimal approximation is about 0.076 or 7.6%.